we are all against regulation. You can't mess with our horsepower, right? Don't put this on. You can't have a catalytic converter in a car. Catalytic converter converts the exhaust gas to harmless components rather than carbon monoxide. It binds it and produces harmless stuff. And then I think back at the skies here in California, like in the 70s in LA, you couldn't see across the LA basin. It was smoggy. And now you can. Some days it's smoky, but now you can see regularly. You can see all the way across the LA basin. If you're in Palo Verde looking across, you can see all the way across downtown LA to the mountains on the other side. And that didn't used to be that way. So some regulation is good. It is. You need it. You need regulation of some sort of government policy regarding the use of the vehicle or whatever it is in society. So this thing with that the governments are doing with EVs is probably necessary. We need to get unhinged from a commodity-based market. Fuel, gasoline, and crude oil is a commodity. It's a commodity. It has sort of a global price. Taxes and so forth that influence how that's occurs in various countries, but it's a commodity. We need to probably get away from that, and we wouldn't be attached into countries we don't really like to deal with. They're not really
How do
friendly
you think? What do you think? And I want to come back because I think you have more to say about innovation areas, but be curious to get your thoughts on different types of hybrids. So whether it's a full hybrid or a plug-in hybrid. So the advantage you mentioned about the ability to recuperate generative braking, theoretically still exists, right? So yeah, your initial driver is you're using internal combustion engine, but then you have a big enough battery to recoup and take that advantage from the EV. And then also in the city centers, if you're living in and you have a plug-in hybrid with 50-70 mile range, whatever you can get, you're still using onboard emission or tailpipe emission free driving in these city centers, but then you have the flexibility to drive further and also smaller battery packs, which eliminates some of the manufacturing costs and environmental impact up front. So with all that being said, what are your thoughts about hybrids at either a interim step or a long-term solution?
Well, that's a good point. The vehicle we're building here is a hybrid. It's a different type of hybrid. It's neither a serial or parallel hybrid, which are the two configurations you find. One type of hybrid, actually the gasoline engine is attached through gears to the wheels. And then when the engine is turned off, it's detached from the gear train to the wheels. So it's just sitting there off. And the electric motor is driving the gear train. The other type of hybrid there is an auxiliary engine and a generator. And the auxiliary engine runs the generator. The generator then charges the battery or runs an electric motor, which is attached to the wheels. So there's no physical coupling of the gasoline engine in the second type to the wheels. That's another type, much like the Chevy Volt. The latter type, the one I just mentioned, is the more expensive one to produce because it has a generator, it has a motor, it's got all these other things on it. The former, which is the coupled system, much like the Prius, is the less expensive one to produce. Both of those have the capability of being able to run on batteries only. Not all hybrids do, but both of them have the capacity to do that. There is advantages to both. The one that has the coupled engine, that is like a Prius, has a disadvantage because the gasoline engine, the internal combustion engine, is not running at the optimal power output. It's not running at a point where the gasoline engine is producing most efficient power. When you're accelerating and going and driving around in your gasoline powered car, it goes through efficiency bands where the gasoline engine is not efficient. And then it is efficient when it's producing maximum power, let's say, and there's a point there where it does. The type of hybrid I mentioned with the generator and the electric motor is the more efficient option. This is exactly what we're building here. I like hybrids. I mean, personally, if I thought that I could get a hybrid that had the things I needed, I would buy one. So happens I own an electric vehicle car.
Yeah, they're kind of getting regulated out to some extent for like the automakers for some of the reasons you pointed. And then also, these ICE bans for entire countries that have been announced for 2030 and 2035 kind of incentivize automakers.
Well, they're using the carbon emissions and so forth. That's nice. And it's nice to care about the environment. As I mentioned, the thing with LA, you have to be concerned about it's really decoupling yourself from a global market of a commodity that puts you in dealing with danger, in my view, dealing with dangerous people. I mean, some of these people like pirates almost you're dealing with, you don't want to deal with them, there's other alternatives. You could be an energy independent country producing all the stuff that you want internally. Few countries have that option. The United States has that option, but few countries do. But, if, like I said, the advantage is you're going to take a chemical and blend it with another chemical and produce electrons or whatever it is, power. It's nice to recover that. And that's going back to what I said originally. That's the advantage of an EV, purely the regenerative component of that, recovering the power that's lost. It cost me $6 to go 240 miles in my EV. $6. That's all it costs. If I have in back here, we have full power plug-in power stations with all that stuff. They're level 2 chargers, which means they'll charge a car in about 6 hours from dead. It costs me $6 to charge my car battery from dead, and I can drive 250 miles. That's a really big incentive to buy an EV.
And you're also in a great place from a sustainability perspective. If you're using solar power at your house, and then you come and you're using the California grid, which is a relatively clean grid compared to the rest of the country, then it's a great option.
This building here is 3 megawatt solar array back. It's huge. Behind the building, we put a solar farm back here. So you could argue, although we're not really in that state right now, that this entire building complex here, this entire business park is solar, is renewable. It is. It's interesting because solar panels, if you put a solar panel and you plug it into your wall, it puts power into the grid, right? It goes into storage. There's not a battery on site. Mm-hmm. There's just stored somewhere. You don't know how it's stored. It's stored in fossil fuels. They're not burning fossil fuels, right? So it goes into this big array that people can use. The power we're generating here on the weekends is used somewhere else in the community around here.
That's very cool.
Yeah, it's stored. So we're taking now, where those panels come from. Are they cheap to make? Are they environmentally? I don't think they're that environmentally friendly. There's a lot of chemicals in them, and they're not being made around here in California. Being made probably in China or someplace like that. So I don't know that equation very well. Like if it's environmentally the friendliest thing to do, but in the short term, just from an emission standpoint, it is.
How about, so going back to your train of thought that I think I cut you off. So you had mentioned energy management on EVs as an area for improvement. Can you speak more about where you see that?
Let me give you the example of the scooter. You brought up scooters, and I sort of keyed in on that. So an electric scooter that you see, the standard electric scooter, let's say Lime makes an electric scooter, whoever it is, mm-hmm. does not have regenerative braking. They a little bit, but the problem with them is that they cannot. Let's say you hook a battery up to an electric motor, you go up a hill, it takes power out of the battery. The battery heats up, right? Then when you go down the hill, it puts power into the battery, heating it up even more. It heats the battery up when you're doing these chemicals. I mean, there's a loss there associated with power generation from the chemical reaction in the lithium-ion battery. And there's also a loss when the power goes back in, separating those ions, replating them. So it's essentially that problem which prevents a lot of the smaller electric vehicles from being fully regenerative. There is areas of innovation in battery chemistry which will allow that to happen. And that would give you an extended range, a large range with a much smaller battery. So if you can figure out a way to keep the batteries cool, I mean, they have a battery management system on them already, which prevents them from overheating. That's all it prevents. Like they shut down if they get overheated or they're drained. But it'd be nice to have one that could also manage the power content and the temperature so that you could cool the battery when you think that the battery's getting too hot. Mm-hmm. Now, big cars like the Chevy Bolt, the Tesla, all have this inside of them already. The batteries are bathed in a coolant, and it's coolant circulated around the batteries to keep them cool and all at the same temperature. But a little scooter does not have that. And a electric skateboard does not have that. So there's an area of innovation for battery chemistry or a cooling system. That's my example here, that you could do some innovation in to cut the battery pack in half and increase the range to have the same range. So there's an area there. And so the area that we're looking at here is there's the hybrid area. Like, how can we make the hybrid the most efficient so that it turns out that if you have a small gas engine on there, and the hybrid we have, we've only charged it twice in the entire time we've had it, plugged it into the wall. You plug it straight into the wall, 120 volts. It's got a little power cord, the charger's on board and everything, twice. And it's always topped off. And the little internal combustion engine, it can't power the vehicle. It's only about, I don't know, 3/10, it's only 3/5 of a horsepower, but it's enough that when you park the thing, that'll turn the generator on, the little generator, and top the batteries off. In addition, if you had a battery, a braking battery, a battery that takes the energy from braking, and a battery that takes the energy from propulsion, two different battery packs. That's what this thing has. It's got two. It's got a smaller battery for braking and a much larger battery for propulsion. So when the thing is slowing down, it dumps the load into the braking battery and it's stored there. And during propulsion, which is going forward, it's taking, accelerating, it's taking the energy out of the propulsion battery. And then when you stop, it tops off the battery, the propulsion battery with the braking battery. And what we were trying to do was to separate these two things temperature-wise, to keep one braking battery at one temperature that's only used for braking, and the propulsion battery at another temperature. So we could control the temperature of the battery, control how the battery is being used, that it doesn't get too hot and so forth, without a cooling system on it. That's what we're trying to accomplish. And then I don't think that we have that working quite well yet, but we're still working. So that's an area, there's tons of innovation that can be done. Here's another one, and I'm going to mention this because this is really, really interesting. What do you do if you have our electric vehicle has no brakes? It doesn't have mechanical brakes on it. It's all regenerative braking, and it actually stops pretty well. It won't lock the wheels up, but you don't want to do that anyways. But it brakes pretty well. What do you do with an electric vehicle? And that is at the top of a hill, the batteries are fully charged. Let's say you live at the top of the hill, you plug it, you drive home, you charge the battery up. And then when you want to go downhill, what do? Because the batteries are charged up, you can't brake using the electric brake because there's nowhere for the regenerative energy to go. And so one thought we had was to put this thing, if you had two motors on this thing, one motor could be in regen mode and the other motor could be in braking mode. You see, on an electric vehicle motor, you can brake them, non-regeneratively brake the motor. You can cause the motor to generate a braking force and it won't generate power out. It won't generate regen power. It'll use power from the battery to brake. So what if you use the rear motor and the front motor? The rear motor would be regen, the front motor would be braking. You could have a braking force on the vehicle without using the battery. So there's an area that I think is
and you know,